Welcome to the Mike Fave podcast. I'm your host, Ethan Wright, joined by Mike Fave. In today's episode, we'll be diving into the sugar diet and FGF21. This has been a topic I've been begging Mike to cover for a long time. So here we are. I'm excited to ask all the questions that I've been wanting to ask for a long time now.
Yeah, I remember back in November, you're telling me about the honey diet, and we should talk about the honey diet, and you need to look into FGF21. You have all these people in the bioenergetic sphere on bioenergetic Twitter who are pushing these different diets. So, I mean, we finally got around to it. It took a couple months to get into it, but we're here now, and I think it's really popped off. It's trending heavily now in the sphere, and it's gone beyond honey diet, right? So now you have sugar fasting, which is Cole Robinson's thing. You have a more of a sugar diet or like a cyclical setup, which is what Mark Bell is promoting. You have the honey diet, which was Anabology's diet, and each one of them is a different iteration on a similar theme. And I think the reason for this push and the excitement around is you have people who have been restricting carbohydrates for long periods of time, and they're now getting into a spot where they're seeing people add carbs in, especially sugars, and lose a bunch of weight. They're posting all their anecdotes online. I think it's starting to get people excited and starting to break some of the carb fear that's been going on for a while. Stuff that we've been trying to break some of the carbohydrate fear for quite some time as well. So it's nice to see this paradigm shifting, but also there's definitely some nuances that we want to get into with the sugar diet that I think are important to discuss overall, because there's definitely some pros and there's definitely some cons.
Yeah, 100%. I think you're right with people who are coming out of low carb, finally adding in carbs back again. I remember when I did that for the first time, and you do feel good. No pun intended, but it is kind of like a sugar high in the beginning. It's like, wow, I haven't had orange juice since I was like a kid, you know? But that being said, there is a lot of questions. A lot of people I think the two main ones that people want to know about are the weight loss. And then FGF21 is kind of packaged within that because that's the mechanism I think people are pinning as what's responsible for the weight loss. And then the insulin sensitivity and diabetes stuff. So we've been shifting away from the fact that carbohydrates and sugar are the cause of diabetes. And more people are kind of open to that idea at this point, which is awesome. It's just crazy. It went all the way from like, they're evil to now I'm just going to put table sugar on my bowl of fruit. So, well, the first one that I think topic that we should get into is just the weight loss one. So I have a lot of questions around that, but if you want to share what your thoughts are around like this kind of movement, as how people are losing like all this weight in such a short amount of time, what do you think are kind of the main things going on there? I know you've mentioned some of these in previous videos, but if you can share those again and we can just go over that.
Yeah, so there's a couple points here with the weight loss that I think are really important. So before we even talk about FGF21 signaling this, I don't deny that people are losing weight with this diet. I think people are actually losing weight rapidly with this diet. Now, the way that they're losing weight though is I think that a lot of people are entering a deficit, because basically if you eat only sugars, you don't have protein, you don't have fat, you wind up being in a circumstance where it's difficult to eat enough sugars to actually hit your caloric target. So I think people are losing weight because they are entering deficits. The other thing is that kind of enters into this picture is that the high sugar intake coupled with the low protein intake drives the FGF21 response. And FGF21 will increase metabolism in these circumstances. In the human studies, we're looking at about 20% increase in metabolism. So the difficulty in getting enough fat and protein in conjunction with having a 20% increase in metabolism, I think is putting people on pretty significant deficits. And then on top of that, one of the things FGF21 does is it decreases the drive to consume sweet things. So it's like you're satiated, you're eating as much sugar as you want, your metabolism's upregulated, you can't hit the caloric targets and your drive for consuming carbohydrates is dropped. So it's like it creates a nice kind of sustainable weight loss regimen in the sense that you're not sitting there like, man, I'm hungry. I can
Mhm.
feel this deficit. It's like you don't feel it, and the weight just keeps coming down because I think people are getting in pretty significant deficits. On top of that, some people are losing weight really rapidly. And I think some of that weight loss is not specifically coming from body fat. I think there's a portion of the initial rapid weight loss that may be related to either stool weight or water weight or things like this. There's shifts in some of these components in the human studies that we saw where they had the young men, they were in a low protein, high carb diet. Metabolism increased about 20%. So they needed to eat 20% more to maintain their body weight, and they still lost 1 kilogram, but they didn't really lose fat or muscle tissue when they lost that 1 kilo. So, some of that could have come from water, other components as well. They didn't really specify exactly what it was in that study. So I think there is some of this going on where people are losing maybe some water weight rapidly initially, the stool weight, just from switching some of the food sources.
Mhm.
And also, I think they're losing weight because they're running deficits because of what some of the things that FGF21 does. So I think people will
Yeah.
lose weight. And I think as far as like a hack, a biohack, or however you want to call it, to be in a state where you can eat as much as you want and you're satiated and weight just comes off, I do think that that is actually happening for people with the sugar diet. But there's some nuances to this picture that I think are important to bring into this as well.
Yeah. And I think that that rapid initial weight loss that you see is similar to ones that you see on keto. And that's a hugely like motivating factor for someone to kind of stick with whatever that regimen is. Um, so that's a psychological piece. But to kind of start, maybe we should discuss what FGF21 is, and then we can get into how you upregulate it through like the protein restriction and some of the studies that you alluded to before about the 20% increase in metabolism.
So FGF21 is a hormone. It can be released by a variety of tissues, like your muscles, your pancreas, your liver. But the liver is one of the major ones, and muscle tissue as well, that will secrete it into the bloodstream. And FGF21's job is to help the body deal with significant metabolic stresses. And so basically you have a bunch of states like overfeeding, ketogenic diets, so high fat, low protein diets, high carb, low protein diets, low protein in general. And then you have things like non alcoholic fatty liver disease, liver injury, ethanol, so alcohol consumption, liver cirrhosis, obesity, type 2 diabetes. These components all increase the production of FGF21. And also starvation and general food deprivation will increase FGF21 because FGF21 is trying to help the liver and the body deal with either a lack of amino acids, too much fatty acids coming in, too much glucose coming in, too much total energy coming in, not having any energy at all. So it's a way that the body is, or the liver is signaling, hey, like we have an issue going on here. So we're going to shift metabolism around for a variety of different circumstances. Now, for sugar dieters specifically, the lack of amino acids, the low protein intake, particularly the branched chain amino acids like isoleucine, leucine, and valine, and the major one being isoleucine, it basically tells the liver, like, hey, we don't have enough building material here, guys. So we need to increase the amount of food that we're eating, right? It's going to increase that metabolism. We need to burn off the excess food that we're taking in, usually in the form of carbohydrates and fats. And we need to try to get more amino acids because we don't have enough building blocks. And so the idea is that, well, if you eat more food, you'll probably get more amino acids and we'll just burn off the extra substrate. And so it's in a way that the body is trying to get all the things that it needs. And then on top of that, you get a further bump when you add the sugars in there, particularly sugars that contain fructose, because the fructose has to be processed by the liver. So you have this low amino acid state and then this high fructose burden to the liver. And the liver is kind of like, oh boy, like we're kind of screwed at the moment. So what are we going to do? We're going to release FGF21. We're going to burn through this fructose. We're going to burn through the food that's coming in. We're going to tell you to stop eating sweets, and we're going to try to get you to eat more protein sources so that you can give us enough amino acids to metabolize all of these components. So in the sugar dieters, they're creating a stress at the liver to drive the FGF21 response. And then one of the things that the FGF21 is doing is increasing metabolism to try to compensate for that stress. So it's an adaptive hormone to a stress state. In most of these circumstances, you have to drive the stress first before you get the FGF21 signaling. So you're inducing a stress response to upregulate FGF21, and then how FGF21 works increase metabolism. That's a whole other story as well.
So the first, what's necessary for FGF21 to increase is the protein restriction. But what you're saying specifically for the sugar dieters is that when you protein restrict plus add the fructose and the sugars, it creates extra stress on the liver. And that's what kind
Yes.
of pushes the FGF21 into a higher gear than if you were to just have the protein restriction by itself and maybe do like a 4-to-1 keto or something like this.
Yeah, so the FGF21 is more strongly stimulated by a high sugar, low protein diet than by just a
Uh-huh.
low protein diet overall. But even if you did a low protein, high fat diet, you would still
Uh-huh.
get an FGF21 response because of the lower amino acid intake. And then also the higher delivery of fatty acids to the liver can also put some pressure on the liver and can also signal some of the FGF21 things. One of the major response elements, one of the major genetic elements that upregulates FGF21 is responds to increase influx of fatty acids to the liver by itself. So it's CREBP. So any increase in the fatty acids triggers this response element, and that increases PPAR alpha and then also FGF21 upregulation. But amino acid restriction is one of the major drivers. Whether you have more carbs or whether you have more fats present, you still get FGF21 as long as protein is low. And then if you add a bunch of sugars on top of that low protein, it further increases the FGF21 response, which is why when Anabology was structuring out the honey diet, it was have no protein in the morning and smash fruits and smash honey, because a combination of the low protein and the honey, the fructose, drove up the FGF21 response.
I see. And so I think the important point here to make, and correct me if I'm wrong, but the FGF21 is a stress hormone. There's been some controversy on Twitter and different people going back and forth whether or not calling FGF21 a stress hormone is appropriate. But it seems like what you're describing is that there has to be some sort of initial stress there for someone to get that upregulation of FGF21 to begin with, right?
Yeah, and the way that not only does an initial stressor drive the FGF21 response, FGF21 works through the stress systems. So FGF21 is a stress hormone. Like there's no other way around it. It
Okay.
works through stress mechanisms and it is induced by stress. It's also a little bit weird for people in the bioenergetic sphere to promote this as something that is like fully aligned with bioenergetics. I don't know if I'm not saying anabology does this. I don't know specifically,
Uh-huh.
but and I don't really spend too much time on Twitter. But these mechanisms that FGF21 is working through is a little bit different than what would be in line with a bioenergetic perspective. When you start to actually look into it in detail, at least from my point of view, because basically
Okay.
FGF21, when it's released by the liver, it goes to the central nervous system and it tells the brain gets the signals like, oh boy, and it starts to increase the corticotropin releasing hormone. Now, this hormone's job is to go to the adrenal gland, or it goes to the pituitary, which releases ACTH, and then that goes to the adrenal gland and tells the adrenal gland, hey, you need to make cortisol, you need to make corticosteroid, you need to make these stress hormones, and also, you need to the CRH will increase the sympathetic nervous system activity. So it's increasing cortisol and it's increasing adrenaline. And the reason it's doing this is the adrenaline signaling goes to the fat tissue, particularly the brown fat and beige fat, and also white fat, and it starts to like beige the white fat, so get it more towards brown fat, and tells the beige fat and the brown fat to increase their burning of energy. So it
Mhm.
signals to these stores, hey, burn energy, like get through this substrate. You need to get through the excess sugars we're taking in, the excess fats we're taking in, and it's doing that through adrenaline. It's driving
Mhm.
that through the sympathetic nervous response. And also we'll talk about the we'll talk about like what's happening in the fat cells in a second. But for
Yeah.
the cortisol and the corticosteroid and the CRH signaling, it will increase in the animal models. We see increase in the size of the adrenal gland and the output of corticosteroid, especially in female animals. So it's increasing our response. And part of that, what's hypothesized in the papers, is to release amino acids from the muscle tissue because you don't have enough amino acids at the liver. And this is not the carbohydrates. So there's an argument in here. It's the carbohydrate. Go ahead.
But I think before we go any further, I have some more questions to backtrack, but I know
Okay.
where you're going because that is a popular question that we see in the comment section. Um,
Yeah.
but I wanna talk about a little bit the increase in metabolism that people are seeing because one of the main concepts that you come into bioenergetics and see is like their substrate, like that has to be converted into energy, right? Which is like ATP. And
Yes.
so that when we see the increase in metabolism with FGF21, are we seeing an increase in ATP production or are we see just a burning of the substrate? Can you talk about that a little bit?
Yeah. So you're not actually seeing an increase in ATP, or
Okay.
you're not seeing, let's say it this way, you're not seeing an increase in net ATP. Because what happens in the fat stores, the fat tissues, is
Mhm,
you either have uncoupling, which
mhm,
FGF21 doesn't have to work through uncoupling. There's kind of some discrepancy in the research, but you have uncoupling where essentially you will take the fuel sources, you'll produce your FADH2 and your NADH. You'll run it through the electron transport chain and you'll pump all the protons across the mitochondrial membrane. And then you won't take those protons and convert them into ATP. You won't run them through ATPase. It won't happen.
mhm,
What will happen is they'll be dissipated through an uncoupling protein and then basically it'll generate heat. So you don't get the ATP, you're just producing heat. Or what also happens, another thing that they discuss in the research is what's called futile cycling. So what you
mhm,
essentially do is you couple a process that produces ATP inside the fat tissue to a process that consumes ATP without producing a net output of anything. So it's just kind of like you're basically on a bike, an exercise bike, and you're spinning your wheels as fast as possible to burn through all the substrate, but you're not actually going anywhere. So it's just a way to keep the metabolic pathways going, but you're just burning through the energy and you're just basically producing ATP, consuming ATP, producing ATP, consuming ATP without any net outcome produced besides potentially the besides heat production to a large extent. Now,
mhm,
in some circumstance, people argue, well, thyroid does this too, but it's like, yes, thyroid does this, but it does this in a state where you are replete with ATP. The thyroid is increasing ATP production because you have enough substrate on board, enough signaling on board. Whereas in this other circumstance, you create a stress response at the liver and in the body, and then the body's just trying to get rid of the fuel sources that you have coming in instead of being like, hey, like we're pretty good on fuel sources. So like we have enough ATP, and then we can try to burn some of this other stuff off or increase the number of mitochondria or things like this. Instead, it's like we have a lot of fuel, but we're missing some of these necessary components. So let's burn off this substrate so we can eat
Sure.
more to try to make up for those components. So it's a minor difference like when I talk about it, but like fundamentally when you break it down, I think that is a little bit counter to some of the ideas that you would look at in the bioenergetic sphere because the fundamental goal is to try to maximize the amount of the amount of energy, the amount of ATP you have at the cell, but like total cellular energy, right? Not just like waste fuel substrate.
Mhm,
So you want to
mhm,
have a state where your cells have the energy they need to function appropriately, not
mhm,
like, oh, I'm
mhm,
going to create stress and I just burn through the substrate. It's akin to cold exposure. Cold exposure upregulates FGF21 to drive fatty acids to the brown tissue to produce heat as well. So it's like it's very similar to like cold exposure and things like this, where you stress somebody out to have this increase in adrenaline to burn, and then you see that this increase in metabolism. It's like yes, through stress. So this is like a
mhm,
very similar mechanism. So it's a hormetic mechanism.
mhm. So the would a analogy be like the FGF21 is creating a release valve for this excess substrate that it's not really looking for at that point because it's more wanting amino acids at that point, and so that's
Yeah,
why
and
you
it
see the fetal cycling and the uncoupling.
and it depends on like because it's triggered by different circumstances, right? So its effects and why it's doing what it's doing is adjusted depending on the context, which makes it a little bit difficult of a hormone to understand because it's
Uh-huh.
also upregulated in states of fasting, but the
Uh-huh.
like longer term fasting in humans will drive an FGF21 response or an overfeeding. But that's because it's involved in switching how the energy sources are being processed, upregulating the burning of fatty acids and things like this during long term fasting, but also upregulated in overfeeding, such they can try to maintain a normal glucose homeostasis and metabolism when you overfeed, so that you don't get fat and drive insulin resistance stuff like this. So it's upregulated in all these circumstances for different things. But with sugar dieting, yeah, you have a bunch of sugars coming in at ad libitum. You don't have enough amino acids, and so the liver's like, all right, what are we gonna do with all this? We can't do anything with this. It's like you have all the material to make a building, but you have no nails, so you can't hammer the boards together. So it's like, well, every shipment of wood that we get a couple nails. So what we're gonna do is we're just gonna get more shipments of wood, get rid of some of this extra wood, burn it in the backyard, so that we can keep getting the nails. So at least we'll have enough nails to make the house. So it's working kind of through this mechanism instead of saying, "Hey, I have enough nails and I have enough wood, so I'm going to make a house and then I'm going to make a shed in the back as well." So it's a little bit of it's a different mentality. I mean, it's not a perfect analogy, but that's kind of what you're
Mhm.
looking at. The bioenergetic perspective is you want the shed, the garage, the house,
Mhm.
and then maybe the house
Mhm.
next door. This
So
perspective is like, well, you'll get the house eventually, but you're just gonna have to waste some wood.
I see. And with uncoupling from really good thyroid function, what is happening there? How is that occurring?
The uncoupling with thyroid function, it does work through some similar pathways, right? There is an
Okay.
increase in heat production. It's similar mechanisms inside the mitochondria. There are some effects inside the brown adipose tissue, and the beige adipose tissue with thyroid. But usually, this with thyroid, this is done in a state where you are ATP replete, at least under normal circumstances. And then the thyroid's also increasing the number of mitochondria and also increasing mitochondrial respiration in general. So this is the context for these two things is different. Um, Overall, even though they have some similar mechanisms, and also thyroid function, if you take mice and you knock out FGF21, thyroid still has its effect. Now there are some relationships with FGF21 and thyroid, but they can function independently of each other. They don't need each other to work. So it's not like FGF21 is working through thyroid or thyroid is working through FGF21, but they do have some parallel pathways, but they're both upregulated in different states. Starvation doesn't upregulate a thyroid
Mm,
hormone, while
sure.
overfeeding may increase thyroid hormone. So that's why understanding the first context of where you're seeing this hormone upregulate and what is it responding to is very important, because I think something to keep in mind with any hormonal or signaling mediator is that it is not the hormonal and signaling mediator is a messenger. It's basically a message. Somebody sends you a piece of mail and says, or shoots you a message like, "Hey, Ethan, there's some guys about to come break down the door on your house. You need to run." And then you sprint out of your house. That's FGF21. So this is
Mm,
like, it's telling the cells what's going on from a systemic point of view. And so that's why the context in which it's upregulated and seeing its effects, you need to have all of that together to know how things are working and why they are working the way that they are to fully understand the complete hormonal picture.
okay. And then one of the things that you talked about in the FGF21 video was around FGF21 resistance. So FGF21 is upregulated in a lot of bad contexts, right? Obesity, insulin resistance, and things like this. So is it how does someone judge like whether or not and maybe they're one of those people who is obese or something like this and maybe already has high levels of FGF21 and then they want to do some sort of sugar dieting thing where they're going to try to use FGF21 as a mechanism to lose weight. Is it possible that that doesn't have the same effect because their body is resistant to the FGF21 hormone?
That is possible. So basically, I don't really have there's not like a blood test that I can recommend right now for somebody that said, "Hey, like you're FGF21 resistant." Like we don't have that commercially available. But what you see in some of the animal models and even some of the human models is in order to actually have um, the FGF21 effect, what you see is if you have obese humans or obese animals, if you upregulate endogenous FGF21 production, it's already upregulated, like it's already high, and the animals and the humans are not responding to the hormone effectively anymore because the fat tissue and the metabolic dysfunction is basically either decreasing the receptor to FGF21. So the cells are like, look, we can't keep burning through the substrate, guys. Like we're burnt out. Like we're done. We just did 80 hours a week for the last 4 weeks. We need a vacation. Like we can't do this. So the cells stop responding. It's almost like they become fatigued to the response and they start down regulating the this response. I'm giving analogies here. If there's like very specific things that happen in terms of mechanisms, but I'm trying to conceptualize it. But essentially, it either FGF21 gets bound up, it gets cleaved, or its receptors get down regulated. These are some of the hypothesized mechanisms. In You have kidney failure, you have heart failure, you have diabetes, you have obesity, you have fatty liver disease. All of these states, FGF21, for at least in a portion of the population, has already been increased, and the body's kind of past that point of trying to use this adaptive response to clear the dysfunction. It's moved out of that. So the way to test it out, the only way to really know at this point, is say you have one of these disorders and you run a sugar diet and you don't respond really well. I'm not saying that people test it out this way. I'm just saying this is the way you would like reasonably do it
Yeah.
right now because we don't have
Yeah.
testing available. You basically would see that the person doesn't really respond well to it. Things get worse. Their symptoms get worse. Their lab markers get worse. So there is the chance that somebody who has this dysfunction wouldn't respond to the upregulation. And in the studies, when humans or in animals, the way they overcome it is they give drugs that are
Yes.
FGF21 analogs that work much
Mhm.
more strongly than FGF21 by themselves, or activate certain components of the FGF21 pathway more strongly than endogenous FGF21 does. So
Mhm.
there is the
Mhm.
chance that if you're in one of these bad states, you may not be able to optimize this pathway because the body's already been under significant stress, already upregulated the pathway, and it's kind of past the point of optimizing that to have the specific outcome you're looking for.
Yeah. And I heard anabology on the podcast with Mark Bell talking about people who have tried the sugar dieting stuff and then maybe gained like a little bit of weight or something like that. And he suggested that maybe it's possible to have an FGF21 polymorphism, so some sort of genetic thing with FGF21. I don't know what your thoughts are on that. And then the second part to that question is around like if someone, I know in the studies they take exogenous, so FGF21 from like a drug out rather than your body's own production, to induce the response. Do you think something like that hits the market and is like similar to an Ozempic style drug that people start hopping on? Um, and I wonder if it would have like the same sort of side effects or things like that that people see with the Ozempic or GLP-1 drugs.
So to the first ones, there is a like serum FGF21 levels amongst different people vary pretty significantly in the research. Like there's quite a range. And then there is the different genetic responses to FGF21. And there's some hypothesis around like thrifty metabolic types with not responding to some of the FGF21 stuff. There's a bunch of hypotheses about it. There's a lot of research coming out about FGF21 because of some of these effects. As far as the medications, there's multiple analogs that have already been produced and
Oh,
have been tested in humans and also in animal models. And what they see is some of them, depending on the analog, will lower weight, but they may not touch something like blood sugar, or they may not touch something like triglycerides or components like this. So there is the chance that you don't see a change in blood glucose and insulin, and you don't see a change in some of the markers that you would want to see a change even if weight drops. But they also see side effects from these drugs. One of the biggest side effects they saw was digestive issues, because there is some when I was going through the research, this was my thought process on it at least. There's some effects of FGF21 on bile acid signaling, which that can change digestion quite a bit for people. I know this very personally. And so some people are developing diarrhea. Also, in some of the studies where they gave humans, this was human studies, they gave them FGF analog drugs. basically what they found is an increase breakdown of bones with with a decrease in bone formation. So there's also studies in animal models where they see effects on fertility, and then they potentially see some effects on muscle tissue and in other studies as well. So there's some downsides that come with these drugs, which those are important things to talk about. So yeah, you may see some drug development, and they may help with weight loss, and they may help with some metabolic markers because they're pushing up metabolism, and they're forcing the oxidation of this substrate. But it may also come with some downsides, which is something that's important to think about. And also, um, the drugs, yeah, with drugs, you'll see people who are non-responders probably respond. For normal people, they could respond even to this the dietary shift, because they probably don't have the FGF21 already highly upregulated. In those disease states, they may need the drugs if somebody has a resistance.
Mm, okay. Um, I want to shift gears to kind of the insulin sensitivity and the diabetes narrative that we see with this diet. So I think a lot of people, like I mentioned in the introduction, are coming around to the idea that sugar and carbohydrates are not responsible for diabetes, and that maybe some of these low carb diets like carnivore and keto and stuff like that are actually contributing to a little bit of insulin resistance. I know that Mark Bell has mentioned that. So maybe just to start the conversation, we can discuss like a brief overview of why it is that sugar would not be the cause of diabetes and actually maybe improve insulin sensitivity when they're included in on the diet.
Okay, so even in the low protein, high carbohydrate diet done in humans to see the response with FGF21 and metabolism, they had a group that was low protein, high fat. The insulin sensitivity, as measured by basically a glucose infusion, like basically a clamp study, a euglycemic clamp, hyperinsulinemic euglycemic clamp. What they found was that they had to provide more glucose to the low protein, high carb group than the low protein, high fat group to actually maintain the blood glucose levels, because the low protein, high carb group was more insulin sensitive than the low protein, high fat group. And this is pretty much known in the research. You start reading the research that having a lot of free fatty acids floating around or running a low carb, high fat diet drives peripheral insulin resistance. It drives insulin resistance. Basically, the goal is to spare carbohydrate for the central nervous system and other tissues that rely on carbohydrate, like red blood cells. And then the rest of the tissues start to run on fatty acids, so that you don't have to break down your muscle tissue in large amounts to provide these amino acids to upregulate gluconeogenesis and produce glucose, because it's not coming in from the diet. So there's the low the low carbohydrate, high fat diets. By lowering the carbohydrate intake and increasing the intake of fats and the amount of circulating fatty acids, pushes towards fat oxidation. And the fat oxidation leads to an insulin resistance. Like, you become more insulin resistant, your ability to use carbohydrate decreases. Um, Now, this is physiologic, right? This is supposed to happen when people are starving, when people don't have access to carbohydrates, they're on a keto diet. Like, this is what you'd expect to happen. If your physiology is functioning fine, like you don't have diabetes or anything like this, once you come out of the diet, you'll go back to being insulin sensitive again. So the thing is, you have studies where you give people very low fat, high carb diets, I think even up to 85% of carbohydrates, even in diabetics, and it actually improves insulin sensitivity because you're lowering the free fatty acids that impair insulin sensitivity, and you're providing mainly carbohydrate as a substrate, which will improve the uptake and utilization of the carbohydrate. So a diet like the sugar diet, which is very low fat and very high carb, it puts you in a circumstance where you don't have free fatty acids coming in, and you have this insulin signaling that can lower the free fatty acid release from the fat tissue to some extent, and then allows for the carbohydrates to be used. And then on top of that, when you have the lowered protein intake, you have a circumstance where the lowered protein intake provides less branched chain amino acids and less substrate for gluconeogenesis, the production of glucose from amino acids. And now you have lower gluconeogenesis, lower free fatty acids, more carbohydrates coming in, and it allows for basically a direct one-way pathway without any roadblocks or anything like this for the body to
Hmm.
use carbohydrate and for the cells to use carbohydrate and respond to the insulin. So in general, the high carb, low protein, low fat will likely improve insulin sensitivity by itself. And then on top of that, the FGF21 burning through all the other substrate, lowering free fatty acid release, taking up fats into the brown tissue and brown adipose tissue and beige adipose tissue, and forcing their burning will further clear that way for the carbohydrate and improve insulin sensitivity. You're clearing out some of the excess substrate, and you're providing all the just like straight carbohydrate while lowering gluconeogenesis. So all of this combined should improve insulin sensitivity in people overall.
Hmm. I mean, that's so interesting. You hear people like even Cole Robinson, like, screaming into the camera saying like, drop the fat, go as low as possible. And even, Mark Bell's talking about basically bottom of the barrel, like fat intake on most days, as well as the super high carbohydrate intake. For someone who is insulin resistant and probably has body fat to lose as well, how do you weigh what kind of dietary set it to put them on? Because you have what seems to be a pretty strong case for dropping fats really low, restricting protein, and really ramping up sugar intake if that's the sole problem you're trying to fix, right? Losing the weight and the insulin resistance, um, versus people who have maybe tried more of a moderate approach and maybe haven't seen the same results, or they're maybe haven't tried anything and they're weighing like which one to go to, you know?
So this is a good question. The thing about it is you need fats in the diet. Like there's a need for fats for optimal functioning and optimal health. And so basically what we're looking at is it's I think these paradigms as just go as low as possible, like or so as low in fat and as low in protein and as high in carbs, like trying to create these dichotomies instead of seeing things as a spectrum is a problem. And instead of trying to understand things in terms of a Goldilocks zone is a problem. Because well, basically what happens, you run into trade-offs at certain points where if fat intake gets too low, and I talked about this in one of the videos. The video is not to like, it's not to crap on the sugar diet or people's weight loss, but it's to let people know like there's some problems with some of these interventions, and you want to at least know what your risk versus reward is before you hop into the dynamic. So if your fat intake gets too low, you may have issues with satiety, right? You may not last between the meals. You may have to eat every hour. You may have a circumstance where digestion starts to become impaired because you don't have the release of cholecystokinin, the delaying of gastric emptying, and the release of bile acids, which help to clear out the small intestine, clear out the bacteria in the small intestine, degrade the endotoxin. You also have a circumstance where when you don't release the bile acids, which is initiated by the fat hitting the small intestine, you aren't able to have the liver detoxify appropriately because the liver shoots anything it metabolizes into or that is trying to detoxify into the bile acids. And then the bile acids are stored in the gallbladder, and then their release is triggered by fats hitting the small intestine and triggering cholecystokinin. So basically, if you don't have the fat release into the intestine, or you don't have the bile acids being released into the intestine, then you're in a circumstance where you can actually pull some of those bile acids out from the fibers in the diet and help the liver detoxify some of the different components that's trying to shoot out in the bile acid. So I think if done on a consistent basis, like say 100-day time frame, which is something that Cole discusses, you could create a circumstance where you create bile sludge, or somebody may be predisposed towards a gallstone, or there could be issues with the liver longer term because you're not providing amino acids, you're pushing high amounts of sugars without the substrate to process them, you're not allowing for the gallbladder contraction and release of bile acids, you're not clearing out the small intestine. I think some people may find long term that puts pressure on their GI tract and on their liver. On top of this, you could have some people who have metabolic dysfunction, say they already had high triglycerides, and then they pushed the sugar diet, and then their triglycerides went up way high. That could be a dangerous circumstance for somebody where they could create basically a pancreatitis. They could irritate the pancreas with the extremely high levels of triglycerides. So it's also not a good thing either. So this is where people want to be careful with some of the dietary setup. I'm not saying it's going to happen to everybody. I'm not even trying to fear monger. I'm just saying that I, number one, have clients who I've seen this happen to and came to me because we made videos about the sugar diet and they're like, hey, I had this problem when I pushed the carbs up too high. They had metabolic dysfunction already, right? They're dealing with type 2 diabetes. And then it's like, okay, you probably want to take a little bit more of a moderate approach and be careful because you can create problems for yourself with some of these different dynamics. So
Uh-huh.
that's some of the major issues without having fat. And then another really important one, if you have guys who have high muscle mass, who have a high activity level, right? Somebody, Mark has high muscle mass, high activity level. If fats get too low, that can really damage or impair the hormonal production or like the steroid hormone signaling and androgens and things like this. In my experience, when I've gone very low in fat, it has nuked my hormonal profile. Now, for Mark, it's not really as much of an issue. He's on TRT. I still think he probably will feel some of those effects, but I think the TRT is helpful in the circumstances. It's not a shot at him. It's just I think the TRT allows you to get away with lower fats overall than somebody else who maybe has more muscle tissue and is pretty active and has a higher requirement for some of those fats. So this is another area where things can be problematic. And then on top of that, FGF21, the high sugar, drives sympathetic nervous activity. And the lack of fats themselves can also drive up some of the sympathetic nervous activity because when the brain senses a low amount of free fatty acids, your body uses both fats and carbs as a fuel, which will bring us into the Randall cycle question I know you want to ask me. But when the when the fat when the body it uses both fats and it uses both carbs, what winds up happening is if you some tissues are going to use those fatty acids like muscle tissue at rest. If you don't have enough fats, you can start liberating them from your own stores, and then it does that partly through the sympathetic nervous system. So when I did this wasn't even a low protein diet. It wasn't even to drive up FGF21, but I did a very high carbohydrate, very low fat diet, and I was anxious, super anxious. It didn't happen initially, but after a period of time, I had to eat every hour. My blood sugar was dropping. I was never satiated, and I was having tons and tons of anxiety, and I was also running into sleep issues. And I think it was through some of these mechanisms, right? The fat helps the satiety, helps stabilize the blood sugar, helps to minimize some of the adrenaline responses, and helps with steroid hormone production. Now, if you have somebody who's heavier, they have more body fat, they may be able to get away with this, right? I have some clients who are type 2 diabetics, they're insulin dependent, they're not insulin dependent, they're on oral anti-diabetic medications. I will bring their fat down lower, not as low as sugar diet levels, but I'm bringing them probably close to 20 to 25% of their caloric intake to try to get them to oxidize carbohydrates a bit better. And they can handle that. They handle that relatively well. For me, if I start going around 20%, I really suffer. So for me, about 80 grams per day of fat is the lowest limit that I tend to hit. Cause after that, after a couple days, like I really don't feel that great. But again, they're different contexts. So your individual context is important in determining how you respond to these different dietary interventions.
Totally. Totally. I know and the one thing too to mention, like, we're all for the experimenting, and people try, like, people are very interested to see what would happen. I mean, even us, like, oh, should we try it? Maybe not. Who knows, right? Um, but there's a spectrum of a way of doing it, right? You have like the fasting where you really are smashing protein and fat like all the way down to zero, and then you have sort of the honey diet setup where you load the protein and the fats all in one meal at the end. And theoretically speaking, you could still benefit from some of the FGF21 in the earlier portions of the day before you have that high protein meal. Because one thing we didn't mention before was that the FGF21 is increased by even just one meal that is low in protein, right? So, do you think that there's any sort of benefit that someone could potentially get in resolving their insulin resistance or some sort of weight loss benefit by having the honey diet like setup as opposed to the sugar fasting setup?
So I think this is a great question because I do see them on a spectrum. I think the 100-day sugar fasting setup, I think I'm pretty much not a fan of that. I would say I'm
Okay.
I'm I'm against doing something like that. Where the water starts to get muddied is Mark Bell's cyclical setups or an anabology honey diet. Now, I would probably be more of a fan at this point in time in an anabology honey diet setup. Especially, I made a video where I took basically anabology's general template, general idea, and I structured out the meals with fruits, 100% fruit juice, dried fruit, and I put some supplements in there to make sure that the person can maintain their nutrient status or micronutrient status. And then at night, they have that protein meal. For me right now, I think that's probably the best option or like the safest option if somebody wanted to try a sugar diet setup or try to optimize for FGF21, because you still provide those building blocks at the end of the night. You still provide that protein source. And one of the concerns with the FGF21 upregulation is in some of the studies, it's not really great for the bones or for the muscle tissue. So at the minimum, it's not anabolic at all. And at the maximum, it may be catabolic for muscle tissue and for bone tissue. There's some discrepancies in the research on this. There's some studies that say yes, there's some studies that say no. But I would say on average, what we're looking at right now is the upregulation of FGF21 is not good for the bones, nor is it good for lean muscle tissue. So the anabology setup allows for the person to have a high amount of, like the honey diet setup, a high amount of protein at night. They could still hit about a 0.64 grams per pound per day so that they can maintain that lean muscle tissue and while they increase the metabolism across the beginning portion of the day to try to lose some of the body fat. Now, again, I want to caveat this here with I think the way that FGF21 is working is not necessarily ideal in terms of increasing metabolism. So I think fundamentally, an appropriately set up diet with an appropriate caloric deficit, I usually shoot for about 20% to start. I think that is hands down the best way to go while keeping protein across the day between 0.64 and 0.82 grams per pound, with probably 0.82 being the better option I would shoot for if you don't have any kidney issues or any other issues that wouldn't allow for higher protein intake. So I think that's the best option. But fundamentally, if somebody has a lot of body fat, they're obese, they have a lot of body fat and they're type 2 diabetic, I think it's important to take off the body fat because the body fat itself will drive inflammation. It'll drive insulin resistance by constantly releasing those free fatty acids. And it can also mess up the hormonal profile by driving aromatization, which is a conversion of androgens into estrogens. So fundamentally, taking the body fat off is important. I think the best way on the spectrum is going to be having an appropriately set up diet where you run a caloric deficit. I usually shoot for 20%, keep protein at a high point, and make sure you have adequate amounts of both carbs and fats and adjust the amounts to hit your caloric target. The next option I would say would be like a honey diet, anabologies type of honey diet, where you still allow the protein at night. Then you could probably have some type of setup where you have like similar to some of the things that Mark Bell discusses. He has a protocol. I actually want to go and look through it. He had mentioned this protocol. So in that case, you'd have like a sugar fasting day, maybe like a couple days a week. And then you had other days, which would be higher protein intake. I probably wouldn't cycle it with like keto or carnivore. I don't think that's a good idea. I think you would probably cycle between a couple days a week. You have a more balanced setup and then you have a couple days where you're doing like a more of a sugar fasting type setup where you just have fruits and juice and things like this across the day. Now, I also want to say here, I think using tons of granulated sugar and honey and maple syrup and especially processed foods like Sour Patch Kids and sodas and stuff like this is a terrible idea for setting up a sugar diet. I think people will lose weight doing it. I think they will. But I think long term, they will create other problems for themselves in the microbiome and also with their micronutrient status and potentially with their oral health. So I think if you're going to do the diet, my personal preference would be to do something with whole fruits, frozen fruits, dried fruits, 100% fruit juice, maybe some honey and maple syrup and a little granulated sugar. But I'd really lean on those other sources because they're higher in polyphenols, higher in vitamins and minerals. I think they'll improve the overall processing. Whereas I think the refined stuff just doesn't have a place in the diet. I think that stuff should really be minimized to as much as possible. And that's, candies, sodas, things like this. I think it really should just be the fruits and then maybe some honey, maple syrup, and some of these components. I think that's really important. And the 100-day sugar fast from Cole, I don't think that's a good idea. I think you'll see people um, you'll see people lose weight on the scale, and they'll lose it rapidly. But the question is, what percentage of that weight is lean tissue? If you go through 100 days of just sugar fasting, and you get to the back end and you lost 100 pounds, but 40 or 50 pounds of that is muscle tissue, I think that's bad news big time, and
Sure.
I don't think that people should be doing that. I think you wanna minimize lean muscle tissue loss as much as possible. So I think
Mhm.
that's why the other setups are much more reasonable. And I think we don't know yet if doing like a Mark's cyclical component or, doing anabologies, honey diet, kind of more like an intermittent fasting type thing
Yeah.
with a sugar fast built in there, we don't know what the long-term repercussions are of those. Just like when we see like a typical fasting regimen, it's like something like what Peter Attia was doing, or intermittent fasting regimens where people are saying, "Hey, I still lost lean mass even though I had high protein, I was doing exercise. After 10 years, I still lost like I was a 10 or 20 pounds of muscle tissue." We don't know if that will happen with the sugar diet stuff. I think there's probably less chance because you still have carbohydrates. You don't have to push gluconeogenesis. You still have nutrient coming in, but there still may be the opportunity that occurs because of some what we see with some of the FGF21 stuff, and basically the priority of the diet being keeping protein exceptionally low to have the response.
Yep. And I think there's a video that you did covering the 4 key problems with the sugar diet, which we'll link in the
Which
description below. And then there's a follow-up video to that discussing how to set up a sugar diet without ruining your overall health. That's your sort of anabology honey diet modified setup. So we will
yeah,
leave that video in the description as well too, along with a template to the chronometer, so that if people want to download that and print it out and try it, obviously we'd be curious to see what the results are from that. And then the question I wanted to ask, which you kind of touched on during that, was, I know you don't have the answer to this question. No one probably does. But if you were to isocalorically keep like somebody's regular diet with protein spread out across the meal, carbs and fat spread out across the meal, or across 4 meals or 3 meals or something like that, if you took that diet and then you took the fat, the protein out of 2 or 3 of those meals and put them all into one later. So calories are kept completely the same. The only difference is the timing of the day at which you eat the bolus of fat and bolus of protein. Do you think that would lead to a faster weight loss for somebody?
I think that based on some of the research, because you can see FGF21 increase after a meal, I think there's a probably a decent shot that you may see a small bump in energy metabolism after the
Yeah.
meals that are low protein and high carbohydrate. So I think
Mm.
you may actually see that. That's why the diet that I set up, which again, like I took Anabology's idea and I modified it with things that I think would be a better setup. That's why I set things up that way where I still hit the protein at the end of the day. Now, if and with clients that I've worked with inside my program or even one-to-one who are interested in some of the honey diet stuff or the sugar diet stuff, what I've done is try to get the last 2 meals of the day, the dinner and then maybe one meal before, if they're like, they don't want a full sugar fast, you could put the protein in those meals and you would still probably be able to maintain lean tissue with that because there are some studies looking at protein timing. And basically, in some of these studies, you could have protein, basically a large protein bolus, and the body will still partition some of the amino acids out, and you may not go into a super catabolic state. I think ultimately the best option would be to spread it out. But
Mhm.
I do think that you can, because again, like the FGF21 stuff, you see this bump in metabolism, but you are seeing it work through some stress pathways. Um, which to be fair, if you're on a
Yeah.
deficit, you'll have some stress pathways as well. So it's like the goal is not to
Mm.
absolutely completely eliminate stress altogether. The goal is just find which mechanisms allows people to lose weight in a reasonable time frame at a reasonable rate, a decent amount of body fat in a decent amount of time, and do so without taking off their muscle tissue and allow them to feel well so that they don't feel like, man, I'm in a deficit. This sucks. I'm so hungry. So for me, that's my goal because at the end of the day, like taking off body fat is exceptionally important because too much body fat does pose metabolic problems for people, like, period. Now, the question, there's a range for how much is too much. Like some of the current standards where guys have to be like sub 10%. Like, I'm not talking about that, but if you're a guy and you're in the 20s, you probably want to be less than 20%. And for ladies, probably want to be somewhere between 20 to 30%, maybe 20 to 25%, men 10 to 15%. Probably shooting for those those points, or shooting for those ranges. So these, I think, are important things to, like, for overall health, to get body composition in a good spot. And it's about finding a diet that allows you to do that with minimal stress to the system as possible, and while having a diet that promotes long-term health and minimizes lean muscle tissue. For me, that's the overarching goal. If somebody has a different outcome, right? I just want to lose weight as fast as possible. I don't care about downsides, and I don't care about if I lose lean muscle tissue. Well, then that's a different prerogative, and that person can go about that in a variety of different ways. But again, for me, my context, my framework is long-term health, sustainable dieting, good lifestyle practices, and then covering multiple bases in the diet, total energy intake, your macronutrients, your micronutrients, all of these components, I think, are really important. So it's the goal is to set somebody up, have them lose that body fat, keep their muscle tissue or build the muscle tissue, and then maintain it over the long term.
Yeah. I guess it's like you said, there's trade-offs, right? I mean, if you want to eat a giant meal, like at the end of the day, for maybe a minor uptick in metabolism earlier on in the day, is that worth like smashing all that protein at the end of the day? And then whatever other downsides come with not having those things spread out. So to each their own, I guess. The other thing I was realizing as you were talking there was like most people wouldn't practically be able to like isocalorically make that work, because sort of the appeal of shoving all the protein and the fat at the end of the day is that you're not tracking this first 3 meals where you just gorge on sugar. So I guess it's just more of a theoretical or hypothetical
It
question.
If you're gonna track it that religiously, then you might
Mhm.
as well just
Yeah,
do a
yeah,
reasonable
exactly.
setup and run a deficit. So
That's what I mean. That's what I mean. It's just those people are not going to track it. So it doesn't make sense. I'm just wondering from like a scientific standpoint, like, does that boost in the energy metabolism earlier on in the day actually lead to someone being able to eat more calories or lose more weight under like, if you're not changing the caloric variable there. Um,
I think the anabology setup where you
yeah.
are basically upregulating FGF21 across the day, because the FGF21 was still upregulated, I think, like 60 something percent 4 hours after the meal. So if
Uh,
you're having a low protein, high carb meal and you're having four of those meals, and then you're only having one meal at night, your fifth meal, because you're gonna have to eat multiple times if you don't have enough fat and
uh-huh.
protein in the meal. You're gonna be hungry, even if you eat a bunch of carbs. You'll probably get hungry. So that meal at night, if that's the only time that you do that, you're stacking the FGF21 response at each meal. They're going to be relatively close to each other. I think you probably would see over time maybe not a full 20% bump in metabolism, but you probably would see maybe a somewhere on a spectrum from 0 to 20% bump in metabolism, which may make it easier for some people to actually lose the weight. And then if they're still hitting the 0.62 grams of protein at night, then they may be able to minimize some of the downsides with lean muscle tissue loss and like having the FGF21 signaling upregulated through the whole time, while also taking pressure off the liver, and then also providing some fat at night to trigger the bile release. And I think part of this is like you'll start to create digestive problems if you try to keep the same macros. So you wouldn't, maybe calories could be kept the same, but macros probably couldn't, because if, like, for me, I'm going to do 100 grams of fat in a day, I can't do that in one sitting. Like, I'll have significant digestive problems. Same thing with protein, like trying to get 100 plus grams of protein in a sitting, that may pose a logistical problem for some people because of how full they'll be or how much food it is. So you run into some new issues with some of these different setups that I think are important to actually consider depending on how the diet is structured. And you basically be forced to be on a very low fat, probably moderate protein or high-ish protein diet with like basically tons high carbs across the whole day.
So another hypothetical question while I'm at it is, if someone were to eat only pure sugar, do you think that they would be gaining weight? Like their whole diet is just purely refined sugar.
I think they would, like, whether they gained weight or not, I think they would run into some significant issues at a certain point, like whether in the microbiome or whether metabolically or from
Mhm.
micronutrient deficiencies, that I think that that's just not recommended. I think that's like a
Yeah.
pretty bad idea longer term, especially with again, health in mind. Like for me, it's not
Yeah.
just lose the weight, it's lose the weight while improving your health. So like you can just have somebody yell at you in the camera all you want about it's, you got to get shredded. But I think fundamentally it's like, no, the goal is from my camp, my context, you want to get into a healthy weight and you want to be able to be overall healthy. That's the overarching perspective. And so if that's what you're looking for, I think a diet like that is not a good idea.
Yeah. It was just a question that Anabology was like Mark Bell had asked Anabology on their podcast, and Anabology basically said no. He didn't think the person could gain weight. So I was curious what your thoughts are on that. But moving on, the question that I wanted to ask, which we've alluded to now multiple times throughout the podcast, and one that is in all the comment sections of all the sugar diet videos, whenever someone brings up the muscle loss stuff and everything, it's almost become like a meme. I think Cole Robinson even mocks people who talk about muscle loss on this diet, but it's a real thing, right? And what you see in the comment sections is that if the carbs are anti-catabolic, so if your glycogen stores are full, if your insulin is up, which is helping inhibit muscle breakdown, and glucose is being used for energy, and you're not breaking down muscle tissue for energy, would that allow you to preserve the muscle mass? Um, what do you think there?
I still think, even though you're not having to break down your muscle tissue for gluconeogenesis, which is the conversion of proteins or amino acids into glucose, then the liver and the body still has requirement for amino acids for other purposes, other processes. That's why amino acid restriction at the liver, it drives a variety of stress responses that basically shuts down protein or mRNA translations RNA translation. So basically a circumstance where the cell stops taking the messenger RNA that was just transcribed from the DNA and translating that into a protein is like we don't have the raw material. And so where is it going to start pulling that raw material from if you don't have it coming from the diet? There's only one store. It's largely muscle tissue, bone tissue, your connective tissue, things like this. So those are where the major store of proteins to a large extent is your muscle tissue. The major store of fats is your fat tissue. The major store of carbohydrates is glycogen in the liver or glycogen in the muscle, but glycogen in the muscle is not accessible for other tissues besides the muscle tissue. Once it goes into the muscle, it's the muscles. So I think in these circumstances, people think that protein just broken down for gluconeogenesis because they hear, like we've talked about that. We don't say it's just for that, but we talk about if you don't have enough carbs, then you'll need to break down you'll have to break down protein to provide that for glucose. Like, oh, well, I have carbs now, so that's not going to happen. Well, protein's used for other components, and the liver is using the protein for a variety of different elements, including anabolism, so building up of tissues, and also the repairing of tissues, the turnover of tissues, and things like this. And so I think, in an anabology setup, will that happen? I think it's probably hard to tell and probably on the lower end. In a 100-day Cole Robinson fast, will that happen? I think you'll probably see muscle tissue loss in that. And while people can wax mechanisms, at the end of the day, like, look, do a DEXA scan or a bioelectrical impedance scan. If you're going to do this diet and see 100 days later, and then we'll see where you're at, how much lean muscle tissue you lost. Ideally, none. Like, I don't want anybody to lose their lean muscle tissue. I don't think that's a good thing. But if I'm working with a client, I would probably advise against doing something like that. And I would basically put them towards a caloric deficit. If they want to do an anabology, like honey diet-esque setup, like the one that I kind of built out, like I have clients, they're like, I want to try this. Like, okay, try it this way. That's why I made that video. Let's see how it goes to minimize some of the downsides. You could try that. I think that may help to minimize some of these effects, but fundamentally, you still have tissue turnover. You have tissue turnover. You have amino acids needed for enzymatic function, for neurotransmitters, for metabolic processes at the liver. And even when you look in the studies, when you push up FGF21, it basically lowers the growth hormone and IGF-1 axis and makes the liver resistant and the body resistant to that axis because basically you don't have the amino acids for that axis to function appropriately. Now, I'm not here to say we need to massively optimize growth hormone. That is kind of counter to the fundamental bioenergetic perspective, but there's two sides to growth hormone. One side is tissue growth and maintenance, and there's an amount of it that's important for that. The other side is upregulating fatty acid oxidation during under periods of stress. So, adequate growth hormone signaling and response for tissue maintenance and structural components and overall growth is important. But pushing up growth hormone because it forces fat oxidation if you're on a low carb diet, that's a little bit of a different thing that I wouldn't optimize for. And I think in the FGF21 circumstance, you have a situation where the growth hormone and IGF-1 axis is being decreased because of the lack of amino acids and lack of anabolism, tissue buildup that's going on because you don't have the building blocks. Like you can't make the house if you don't have the bricks, and the bricks aren't being supplied. So it's like the body's like, all right, we're not gonna build this stuff. We can't respond to this signal anymore.
Um, so for someone then who wants to include protein in the diet, but maybe is insulin resistant and stuff like this, what is that kind of lower end of protein restriction that you would shoot for or recommend for them to hit?
So basically, the lower end of protein that I typically shoot for is 0.64 grams per pound per day to maintain lean muscle tissue, especially if somebody is losing weight. Could they potentially go a little bit lower? Yeah, they can. I think as low as like, even if they go like, I think it was like 15% in some of the studies, you could still optimize insulin sensitivity. But even for myself, I'm on 170 grams of protein a day. So that's 680 calories, and my total intake is 3,200. So divided by 3,200, that puts me, I'm about 21% protein intake. If I went to 0.64 grams per pound, so I'm 195 pounds right now. So that's 124 grams. So we'll do that times four. So 500 calories divided by my 3,200. That puts me about 15% of my caloric intake as protein. So I would just adjust my protein intake down from the 0.82, which is roughly the 170, down to the 120, which would put me at 0.64. And that may help to improve my insulin sensitivity. And I have done this with clients. If I have a client who is type 2 diabetic or is struggling with blood glucose regulation, they're coming off low carb or especially carnivore, I'll probably keep them on a 0.64 grams per pound per day. And I will keep maybe fats a little bit lower. I won't do it at first. I usually titrate the fats down and find an appropriate level where they don't feel bad from it or mess up their hormones or their digestion. Because you're coming from really high fat, you can't just go, I go 120 grams of fat today to I go 50 grams of fat today right away. That can create some problems for people or ramp up carbs super fast if somebody's dealing with blood glucose dysregulation. So I titrate them down slowly to that point and find a spot for the individual that like, okay, I actually feel pretty good here. I'm not craving fat. I'm not craving carbs, not having blood sugar swings, but I will bring the fat down. Say I have somebody who's type 2 diabetic, they're obese. I could probably bring them down to 20%, increase the carbs a bit more. Again, whole food based carbs. I'm not really even using juice with those people. I'm using whole fruits, potentially tubers. And in protein intake, it will depend. Like if they do fine at 0.82 grams per pound, great. 0.72, great. If they do a little better with their blood glucose regulation and their insulin sensitivity at the 0.64 grams per pound per day, then I'll run something like this. So I'm just toggling based on, you know, where they fit best. And if somebody is typically, if they're defined as obese, though, I will run 1 gram per pound because if you try to do 0.82 or even 0.64, it may give you a really high amount. So I'll kind of adjust
Right.
based on the circumstance. And I'll toggle the different macronutrients to see if I can get the effect. I don't like bringing protein too low though, because again, I my goal is lean tissue maintenance, and I think protein has a variety of benefits, and a lot of the protein foods too, like your steak, your chicken, your eggs. If you tolerate dairy, your dairy sources, those are super nutrient dense. So cutting them out of the diet, you may miss out on some really important micronutrients as well.
Hmm. With the carnivore diet and the keto diet, I know that the carbohydrate intake is important for the insulin sensitivity and whatnot, but the carnivore diet is obviously much higher in protein for most people than it would be if they ran like a traditional keto setup. And I think what we're seeing a lot with the carnivores right now, and Shawn Baker's included in this from some of his labs, it looks like, is that they see over time an increase in like hemoglobin A1C, an increase in fasting blood glucose, an increase in fasting insulin. So do you think that the over intake of protein is responsible for that?
I think the combination of lower carbohydrate intake plus very high protein intake over time will drive up people's A1Cs and their fasting blood glucose and carnivore diets. And I think on the spectrum for that, carnivore is probably worse than keto because keto protein intake has to be kept at a reasonable level so that you don't actually force too much gluconeogenesis, which can count, like basically push you out of ketosis. So fat intake is paramount in keto, and then protein intake has to be kept at a certain point. Carnivores tend to go really high in protein, much more than they need by far. And then, I think now you're pushing gluconeogenesis, and then you're pushing insulin resistance with both of those states. The gluconeogenesis itself, glucagon, and the upregulation of gluconeogenesis can decrease insulin sensitivity. It does this adaptively. It's supposed to do this because the gluconeogenic push is indicating a state where you don't have carbs. So your body's like, all right, well, we're going to decrease utilization peripherally so we can spare the carbohydrate that we're producing for the tissues that need it. And that's why I think you see this shift happen. And in carnivores, they really push that gluconeogenesis, and then they also don't have the carbs. So they're also forcing the release of free fatty acids and fatty acid oxidation, which will further impair insulin sensitivity. So you create kind of a nice, perfect little storm where you have an increase in physiologic insulin resistance, unless they're type 2 diabetic already. And then they have an increase in gluconeogenesis. And now, yep, A1C bump up, and then fasting glucose bumps up. And that's why you see somebody like Shawn Baker, at least the last labs I saw him post for his A1C was with Rob Wolf. I think he was in the 6%. And the fasting glucose was, I think, great in the 1 teens or 120s. It's like, yeah, that's what will happen long term on the carnivore diet. And even I think Shawn cited a study in an Instagram post recently where he said, well, even in a very low carbohydrate diet, uh, you see a negligible increase in gluconeogenesis, but the study he cited was 11 days, and there was actually a 14% increase in gluconeogenesis. So even in an 11-day time frame, you're seeing a bump up in the gluconeogenic response to the extent that on a very low carb versus a normal, like not even a high carb diet, a normal carb diet, you have a 14% increase in gluconeogenesis. So that compounds. But I think
Yeah,
that
yeah.
compounds longer term,
Yeah,
especially
yeah,
if then
totally.
protein is high.
100%. That's the kind of, yeah, it makes total sense that in that frame. Um, this is a little bit in line with that question. What do you think about the carnivores that say that the result, the higher hemoglobin A1C is actually due to the longer lifespan of the red blood cell?
If you have red blood cells that are floating around for a longer period of time, they have the increased ability to become glycated because they have a longer exposure to
Mm,
glucose. So that does happen. But if your hemoglobin A1C is in the sixes, that's cope. Like straight up, that's cope.
okay.
I'm not, I know I usually don't make statements that strong, but if you're
Yeah.
running in the sixes and your fasting glucose is high, like that
Yep.
is I think that's cope. If you're like 5.6, 5.7, you run a carnivore diet, your hemoglobin and your hematocrit counts are bumped up, then maybe you could make an art and say like bilirubin is on the lower side, which is an indicator of red blood cell breakdown. Maybe you can make an argument then that it's like, and there's even a formula, I think. You can say, okay, like this
Goodness.
A1C value is probably lower. When you start pushing over into the sixes, though, I think you're starting to say, like, okay, maybe I really am upregulating this gluconeogenic response. And then you start looking at your fasting blood glucose and you're starting to pull over 100, 110, maybe into the 120s. And it's like, okay, this is upregulated gluconeogenesis. And in the face of increased peripheral insulin resistance, it's like this is not really an ideal circumstance metabolically, at least from my perspective.
Gotcha. And before we wrap up, let's go over the pros of the sugar diet, the cons of the sugar diet, and how someone should decide whether or not they should do the sugar diet or try an alternative approach, maybe a more moderate approach.
Okay, rapid fire, rapid fires. So the pros of the sugar diet are that it increases carbohydrates, gets rid of the carbohydrate fear, particularly sugars. If it's done appropriately, and you respond to FGF21, people will probably lose weight pretty quickly because you can see a 20% increase in metabolism with a decrease in drive to eat carbohydrates, which will leave you into a caloric deficit, which will lead to weight loss. It also will likely improve insulin sensitivity by lowering gluconeogenesis and lowering the free fatty acids and forcing the carb oxidation. Then on top of that, the FGF21 regulation or upregulation, FGF21 does have some positive effects. It has protective effects in disease states against for the liver, pancreas, heart, kidney, stuff like this. Usually it's induced though after there's already stress induced to those tissues. The downside to FGF21 is that the way it's increasing metabolism is it's doing it through stress. It's doing it through the sympathetic nervous system. It's doing it through corticotropin releasing hormone in the hypothalamic pituitary adrenal axis. And it's also upregulating metabolism by increasing the flux of our fuel sources basically through uncoupling and through futile cycling. So we're not getting a net increase in ATP. We're just kind of wasting the substrate. There seems to be some potential negative effects for lean muscle tissue and for bone tissue. There seems to be some potential negative effects on fertility. So these are things to keep in mind overall. So you could lose weight fast. You could feel satiated, eat as much carbs as you want, but you may have these other downsides with stress hormones, muscle tissue, bone tissue, fertility. And so, yeah, so that's kind of the pro versus con picture. And then when we're talking about who should do the sugar diet or who shouldn't, if you're somebody who can't follow through on like a structured diet and you're not willing to do the work to actually structure out your diet, you don't care about longer term ramifications, you're less concerned with your overall health, and you just want to see weight loss as fast as possible, and you aren't FGF21 resistant, then maybe a sugar diet setup is something that you would be interested in. If you are somebody who's okay with going a bit slower in weight loss so that you can actually try to maintain or retain as much lean tissue as possible, and you want sustainable long-term health, you want to avoid some of the potential ramifications of the sugar diet setup and FGF21 signaling because we don't fully know what those are going to be. We have some ideas based on some of the research, and you want to minimize some of the issues with liver, digestive function, hormonal function, blood sugar swings, and stuff like this, and you know that you can follow a structured approach, then I think a appropriately set up caloric deficit with a higher protein intake, 20% caloric deficit, is probably the way to go. And then obviously incorporating resistance training. So I think that would probably be the best way to go in that circumstance. Now, the middle ground is like an anabology honey diet setup where you basically load your protein in the back end, the last meal of the day, probably going to shoot for 0.64 grams per pound per day of protein, and then have fruit, whole fruit, 100% fruit juice, frozen fruit. You have that all across the day with probably some micronutrients like B vitamins, calcium, magnesium, maybe some zinc, so that you can actually hit your micronutrients and use high quality carbohydrate sources to basically upregulate the FGF21 signaling. That is probably like the midway point between both of the setups. The one thing I think that's really important to think about here as well, if you're somebody who's not going to really follow through or ever structure out the diet and doesn't care about your long-term health, I think you need to think where are you going to land when you finish this diet? So when you finish this setup, will you be able to sustain your results, or will you put yourself in a worse place because you're gonna rebound and go back in the other direction? I think for somebody like that, you want to be really careful with running some of these fad diets because you can ultimately make yourself worse if you take off that lean muscle tissue. And then you will have to, at some point, put some structure back in your system so that you can build up that muscle tissue again through resistance training and through proper dieting. So I think fundamentally, it's the most important thing is to develop really good quality habits around your health, around your nutrition, and set up a system that works for your personal lifestyle so that you can reach your goals and then achieve them over the long term, including maintaining your long-term health so you don't run into issues. I think for some people, though, the fast results of some of the sugar dieting stuff, just like the fast results in keto, can kick people into gear and start to be like, hey, like I'm getting some results here. I want to change other things in my life. I want to improve my overall health. I want to go to the gym and start working out. And in that circumstance, I think that's probably a benefit for some people. So again, these are all things to consider. There's a lot of individuality in which option you're going to choose based on your goals and based on your priorities. And I think I would look into those before you embark on the diet and understand some of the potential pros and cons. And these are the things coming out of the research.
Okay, I think that gives everybody a lot to chew on for this podcast. I'm sure there's going to be much more content coming out about the sugar diet and FGF21 because I don't really see this trend slowing down anytime soon. I do want to remind everybody that if they haven't already seen the videos that Mike's posted on the channel, we will leave them in the description below. So that's the 4 key problems with the sugar diet. That's how to set up a sugar diet, and also the template for the chronometer setup for that diet will be left in the description below. Also, the best and worst sugar sources to include on your sugar diet. And you can see all those in the description. For me, you can find me on Instagram and Twitter. I'll be probably a little bit more active on those now. So, and Mike, where can everybody find you, and what would you like to say to everyone before we sign off?
Yeah, I would like to just let everybody know that I think ultimately sit down, weigh the pros and cons before you embark on a decision. Know what you're getting yourself into with any different dietary strategy. There's always going to be pros or cons. And then if people want to find me, they can check me out here on my YouTube channel, Mike Fave YouTube, or they can check me out on my website, mikefave.com.